So, hello everybody, good day, warm welcome to our today's webinar. The topic today is TR-369 USP Unleashed, Proactive Wi-Fi Care and Data Streaming. With me today is Juri Kostelak. Juri is a long-time solution engineer and tech sales here at Axiros. He brings with him some years of experience with some of the biggest telcos and most complex setups within these telcos here in EMEA. All his real life expertise from these dozens of telco projects he will bring today also into this webinar. The webinar itself will take around 45 minutes for your agenda planning. We will record this webinar, and if you do have questions, please place them down here in the questions box. So whenever Juri finishes his presentation, we will of course answer all these questions in the questions box. Then, having said this, TR-369 USP of course is one of the major topics here in our company, Axiros. We are following this TR-69 protocol already since the advent in 2004. And we are proud to claim ourselves as market leader when it comes to TR-69, TR-369 and USP. We have a full solution portfolio around TR-369 USP, not only on the server side, also on the protocol side, on the client side with a good agent. And having said this, let me hand over to Juri. Juri, is your presentation, your playground.
Thank you, Kurt. So, hello everyone from my side as well. I am Jure. I am a technical account manager here at Axiros. My position is more of a mix of, let's say, sales and technical understanding of the domain as well as our solutions. So for our sales, I am the tech guy, and for the tech guys, I am sales, so somewhere in the middle. I am by no means a USP expert, but I would like to use this opportunity to bring the topic a bit closer to you, to our customers, and in a way just try to propagate what USP is and how it can be used and what are the new things that come with it. Besides that, so starting first with USP, also known as TR-369 or User Services Platform. Later on, moving into AX Wi-Fi, which is our Wi-Fi management, troubleshooting and optimization product. And then I will make a kind of a combination, see how AX Wi-Fi can benefit from USP, and then coming into a different topic, which is streaming, which is something, let's say, new that we're developing and is available. And in the end, after finishing everything, we have some time for questions. So please, if you have any questions, you can write them down, and then I will cover them at the end of the presentation. So, as mentioned, TR-69 has been the de facto way of device management, CP management since a long time. It is present for over 20 years. It is, I would say, well known and well distributed amongst the manufacturers of the devices, as well as people like us providing the device management platforms and software. And the USP or TR-369 is this natural successor of TR-69. It is, in a way, it has been defined for some time now by Broadband Forum. We are also active in Broadband Forum, and most notably on the USP side and defining the protocol itself. One key point to know here is that USP isn't, let's say, something which will tear down everything that TR-69 has made, but rather trying to fill the gaps, or based on this 20-year experience, to upgraded the sites where we saw that TR-69 is lacking. So I would try to give this presentation, or let's say the first part of this presentation, as more of a comparison between TR-69 and USP, and see how some of the use cases or problems are being solved here. And the first point I would be is the choice of transport, or the way how on the network layer the protocol is utilized. With TR-69, we have a defined stack. So it is HTTP based, most notably SOAP based, so using XML to define the structure. Then we have the remote procedure calls on top, and the CP or the ACS management platform. With USP, we have the ability to choose the MTP or message transfer protocol, and it can be chosen based on the use case. So knowing for a specific use case, type of device, or what we are trying to achieve, we can choose between the following. So one of our preferred ones would be WebSockets. WebSocket is a protocol which allows us to encapsulate a single session between the USB controller and the device. So having direct connectivity to the device, and then this is how we would exchange the messages between the device and the ACS. Alternatively here, which is really dominant in the field, is MQTT, a pub/sub protocol, which I would say is most notable in the IoT industry and this part. So it uses a broker, MQTT broker, and in a way the USB controller would interact with it. So subscribing on certain topics in order to receive information, or pushing to the broker to execute some kind of operations onto the device. The least common between the three, I would say, would be Stomp. Stomp is, I would say, also comes from the IoT world, and it is a message queue based one. In my experience working with USP, I haven't encountered Stomp yet, but of course, when the need comes and we need to, let's say, support it or find a use case which would prefer Stomp, then of course it is well supported. Some of the points about USP and the message transfer protocols is that I will come to it later, but the idea is that we can mix and match different protocols even on a single device or on your fleet of devices based on the specific use case, and then having multiple USB controllers that can then work on the same device. Next point would be that the protocol or the connectivity is always on. With TR-69, it is a session-based communication, meaning that the TR-69 session is always initiated from the device's side. The device and the ACS exchange some messages, exchange some commands, and then the session is terminated. Some of the issues that we noticed here is that we, on the ACS side, need to also size our solution based on certain spike loads. So for example, if we're trying to do a campaign, so a massive operation on a group of devices or even the whole fleet, so for example, doing firmware upgrades, we would need to be ready that the whole solution can handle the load of this particular operation. Additionally, some scenarios like power outages at a certain district can also cause these issues. So the power goes down, but at one point the power comes up, and all of those devices would then send a boot inform to the ACS, and also this is something that needs to be handled. On the USB side, we use a direct communication. So most notably in the WebSocket situation, we would know when the device is online or offline. So additional issue with TR-69, or I would say a big question, is how do we actually know if the device is currently online? With TR-69, since the session is always started from the device's side, in case ACS wants to get to the device, it needs to send a connection request. But what if we get no response from this connection request? Does it mean that the device is offline, or does it mean that there might be some issues in the network in between? So using USP, having this direct point-to-point connection from the USP controller to the device, we would know exactly if the device is online or offline, or even the, let's say, in which situation it would go offline. One more issue which this direct connectivity solves would be the device's connectivity in case of NAT networks, or meaning that the device is behind a internet gateway, so on a private network. We know that IPv4s are expensive, and then having each IPv4 address for each device is not practical. Usually some of the devices, for example, Wi-Fi extenders, would naturally sit behind a internet gateway, and in order to manage them, there are a couple of ways or alternatives which we would use to solve it. One would be to locate a connection request proxy onto that specific network. Another one would be to use a XMPP server, which would then hold a session between the XMPP server and the device directly. So we would then tell the server, hey, can you please let this particular device know that the ACS needs it? STUN servers work on the same principle. They're UDP based, currently obsolete, but there are still a lot of devices, legacy devices out in the field, which would require STUN, or let's say only support STUN and not XMPP. And coming back to USP again, having this direct communication, we solve the issues with NAT, CG NAT, especially useful for LTE, 5G networks, and so on. Another point is the protobuf encoding. So for TR-69, we said that we have a defined structure, that it uses SOAP, or rather a XML defined body. But the issue is that this definition hasn't been fully defined, and what we encounter sometimes with customers, or rather with certain devices, is that this leaves for device manufacturer interpretations. So sometimes, even if it's defined, certain blocks can be a bit different, which then cause problems with the TR-69 handlers, with the controllers, and then we had processes where we would contact the provider, and then they need to contact the hardware manufacturers, and then we need to agree or do some changes and so on. With USP, we completely remove this by having strict encoding and a strict structure. So in order to test it out or to decode it, we will automatically see if this is something which is usable or it is not usable at all. So it doesn't leave room for half-made solutions. One of the also key points here, it doesn't have this chatty XML form, which we call it, meaning that the form takes a lot of the session itself, meaning that the structure of the message is, I would say, majority of what we get, while the actual information is really minor. So by having this, let's say, more strict structure, which only has the information that we need. We then improve on time, we then improve on load, and then overall the stress on the system, the device, and the network. And I think all of these points are going into this direction, that we are losing the TR sessions entirely. So as mentioned before, they are pretty inconsistent, meaning that yes, we can set up periodic informs, knowing when the device will come to us, but this doesn't mean that it will always happen like only like this. We have other events like the bootstrap boot events, in case some diagnostics are being finished and so on. TR sessions for us in particular cause scalability issues, meaning that we need to prepare a sizing which will cover all of those edge cases. So certain campaigns, certain mass operations, while with USP, we have a more consistent load, we have a always active connectivity, and the increase in those particular channel. So even if we're doing a campaign, has minimal impact to what a TR-69 session would have. One of those reasons, as mentioned before, is this chatty XML format, meaning that the actual useful part of the session is minimal. And one more point, the sessions have expensive handshakes, especially if we're using TLS in order to encrypt or secure the communication. We would always need to check it and so on, while on USP having this persistent connection, we know that we do it once and that session can last for days or even longer. Sophisticated notifications. So since the dawn of CPEs, the main focus was the configuration of the device. So you would have a device, you would send it to the customer, and then you would need to configure Wi-Fi, voice over IP, and other services. And I would say when this has been handled, the question was what's next? And what we noticed with TR-69 or having all those devices in the field, the idea is to try and monitor those devices, or rather use the same solution or the same way as managing the devices to actually fetch the information from the device. So the next big step would be to get the info, make some KPIs, and then act upon this. How is it done in TR-69, the monitoring? Most common way, so there are a couple of ways, but the most common way would be pulling the information from the device on a periodic inform. So we would set the device to inform, send an inform every, let's say, 1 hour, 30 minutes, sometimes even less, to 15 minutes, 5 minutes, and then we would request either a certain set of parameters or a single parameter, and then generate the KPIs based on this. Usually the polling method isn't as practical, especially in terms of TR-69, since the size of the messages as well as the load which is being put on the device. There are other options like the parameter listeners, so setting parameter listeners on certain KPIs on value change. So for example, if we're monitoring the RSSI portion of the device, we can only get notified when the value is changed, knowing that if it's consistent, it doesn't mean much to us. However, this isn't supported by all parameters. Some subtrees are only generated when a change happens, meaning that, for example, the host subtree having connected devices onto the Wi-Fi network of the gateway, and first you would need to have a parameter in order to set the value change. So also this would require some additional workarounds in order figuring out when a additional parameter, or rather a host, has been added to the subtree. And finally, when we fetch all this information, all the filtering would need to be done on the ACS. So we would get a certain subtree of that particular data model and do the filtering. While on USP, we have a couple of changes which honestly benefit, I would say, the monitoring part even more than the management part. One of them would be the subscriptions. So they would work similar to parameter listeners on TR-69, but we have the possibility to add wildcards to those particular subscriptions. So if we know where the RSSI parameter of a connected client is located, we can add a wildcard that whenever a new device is added, we also collect this information without any additional checks onto the device, seeing if there's something new, etc. And this is tied to something we call edge computing. So pushing the filtering, pushing the actual extraction of meaningful data to the device itself, rather than us being those who fetch the whole subtree and then filter it on our side. One important, let's say, substitution to the periodic polling is the bulk data collection, where we would define the profile for the device. We would there mention all the parameters which we need to collect, and then tell the device that periodically sends us only those parameters, rather than us always asking in the TR-69 session for the same ones every 5 to 10 minutes. So in a way, as you can see, USP goes in this direction, that it enhances TR-69 and how we use it. So on the management side, but also on the monitoring side, in order to lower the stress on the network, on the devices, and on the OSS systems as well. And one last point to compare here are the multiple controllers. So TR-69 has been designed that you only have a single ACS. So you defined one ACS URL, one endpoint, and then that ACS is the king. That ACS does the configuration, does the monitoring, has the access to the whole data model, and then a lot of customers use the ACS and its northbound systems to northbound interface to interact with other systems in order to fetch the data and to extract. While with USP, we have the possibility to use multiple USP controllers. And the interesting part here is that they can be split by use cases and restricted to the data model of the device only for those specific use cases. So for example, we have one USP controller which is dedicated to Wi-Fi monitoring and Wi-Fi management. You would restrict that part of the data model, and then it takes care of that part. Then you can have an additional one which is dedicated to VoIP. You can have a third one which might be used, if you're a wholesaler, it might be used then for any other smaller customers which you onboarded onto your system, and then only extract data which is relevant to them. And this is also, I would say, pretty important for countries where GDPR is king, where it is important that it is being covered properly. So having this ability to do multiple controllers, and just to come back to the MTP selection slide, those controllers can then have different MTPs, so WebSockets, MQTT, Stomp even, and then based on that, you can switch it and you can distribute it across different systems which require different information. And here I have just a screenshot of a USP agent. So why I added this slide, I would say it's one which is rather important for me, and it's been related to developing, let's say, use cases or figuring out for what USP would be good and would bring additional information. So USP agent here, which is used, is our exact, so on the client side. And this is running on a Raspberry Pi, and the whole idea is to try to push the limits of that particular device and of the agent and the ACS in order to stress test to see how fast can we get the information from the device, what can we do with it, testing out the bulk data configuration, the different subscription modes, and so on. So in a way, trying to bring us to be a USP, call it master in this particular form, and just trying to understand how to better bring benefits to our customers and to really use USP as it is something new and newly added into the whole device management sector. Here I have a couple of slides just to demonstrate the deployment versions. So why I mentioned all the MTPs is because it also invokes certain configuration points. So when we have a WebSocket, we have our Access ACS on top connected to the USB controller, and then the USB controller uses the WebSocket interface to directly connect to each of those devices. The benefits here are that from our side, we can directly see the device, we can directly interact with it, but we also need to be sure that our USB controller handles all of the load of these devices. So if we're talking about millions of devices, it needs to be done and configured correctly. While on the other hand, in case that we have MQTT, we are reliant on a MQTT broker, which is provided by the customer. The benefit here for us is that we give the robustness and let's say connectivity handling to the MQTT broker. We work in MQTT client mode and then use the broker in order to subscribe to certain topics or to push certain configuration to the devices, or rather the operation. So one note here is that customers do provide this MQTT broker, but one question would be, okay, what if you do not have a broker? For that, we have a third deployment scenario where the USB controller works in MQTT server mode. So this is pretty similar with what we have with WebSockets, but the underlying MTP is MQTT. So one point of this is just to show you the connectivity options. How does this affect the USB controllers, but also knowing that even if MQTT is preferred from the client side, we have the ability to integrate either with the broker or to provide a server on our side. So everything is being handled accordingly. Okay, and now I'm entering a portion which is related to AX Wi-Fi and the Wi-Fi expertise framework. Since this, I would say, isn't the main topic of this webinar, I will just quickly mention the functionalities and what do we benefit here from USB. So AX Wi-Fi is used for devices Wi-Fi section monitoring, troubleshooting, and then optimization. So we have the possibility to fetch the data, collect the data, generate KPIs, proactively analyze it, and to see if any problems will happen. We then have the operations part, optimization part, which takes all this information and then can be either scheduled to automatically optimize those devices or on demand. It can be done at certain points of the day. It can have criteria like if the Wi-Fi interface is being used of the device and so on. So we have the ability to cover different use cases. And the third part, which is related to troubleshooting, is more for the customer support personnel. So we have a dedicated slide where we show all the problems found on this device and basically guide the customer support in order to know what to do to resolve any possible issues happening with the customer's device. Just a quick overview of what we have here. So if I can just quickly grab a laser pointer, X Wi-Fi is located here. It needs the communication with the devices using a data collector. In our case, that would be extract, and having an ACS, which does the managing portion. And this is how we would communicate with TR-69, SNMP devices, any enabled devices. But for USP, what we can use is actually directly connect to the USB controller, where we have then the possibility to fetch the information, to push the configuration, or any other kinds of actions we want to do with the device. Just a couple of screenshots related to the customer support portal. So one of them is related to just a general overview of the device, knowing the CP ID, MAC address, hardware and software version, product code, and information related to the Wi-Fi interfaces. So what is the SSID, passwords, channel configuration, auto channel enabled, and so on. And this is the troubleshooting tab. It is important for the customer support personnel. And I always say in my presentations, if I was on the helping side, I would automatically go to this page and see all of the issues which are happening on the device. This is currently the mockup page, meaning that it displays all the possibilities which can happen to the device. But reading this page is pretty simple. It's on the left side, we see what is the problem which is happening to the device. And on the right side, we see the solution. So what is the action necessary to fix it, and a quick description of how this would solve the issue which is happening with the customer. Additional views related to the Wi-Fi optimization. One notable is the Wi-Fi neighborhood scan. Some issues caused on the Wi-Fi side are related to what we call Wi-Fi pollution, meaning having a lot of Wi-Fi networks active at the same time, or most importantly, operating on the same channel. Usually the configuration done by auto channel selection on the device really only considers the channels which cover the main specters, such as channel 3, 6, and 11. But with our view of all the neighborhood and what is happening, we can then really select the channels which would give us the most coverage and the best option there is. On the bottom side, we can see more information about the connected clients. And talking about the connected clients, we have the network map, which then puts this list into a tree structure. So starting from the main node, we can see all those devices which are connected either on different bands or even connected locally via the LAN network. So all this information is grabbed from the main node, main router, and we only operate on standardized protocols like TR-69, or in this example, most notably USP. And what USP also brings here to the table is the effectiveness of retrieving data or pushing the data like configuration to the device. And the last portion of this presentation is related to streaming. In Axiros, when we talk about streaming, maybe to give a bit of context, a lot of requirements from the customer side is seeing or monitoring the device as much as possible, meaning that even in terms of seconds, we get the data from the device, we collect it, we read it, and then we're trying to do some kind of troubleshooting or checking what is happening to the device. The idea is sound, but then we have some other problems, which is we're putting a lot of load on the devices themselves, on the network, executing sessions or executing requests every couple of seconds. All this information then needs to be stored somewhere, going into the database, and then we have a server which reads from the database and forwards the information directly to the GUI. And the whole idea of streaming is to try to mitigate the necessity to go through a database. So why do we want to store all this data in the database, increasing the necessary resources for the system? And then database operations are usually expensive. And what we're aiming here with the streaming part is actually getting the information directly from the USP controller into our Extreme server, and then showing this information on the GUI side in a native way, which is then covered and handled for, let's say, any application. What I have here is a quick video demonstration. So this is a device that we have connected, and we're executing this streaming part. And as you can see, the data is really being refreshed in terms of seconds from the device to the USB controller and presented on the GUI side. You might notice that the GUI doesn't look like your standard Axiros support portal, but the idea here is that this widget or this functionality doesn't have to be limited or injected only onto our ACS. It can also be used in your care portals, your self-care, or even technician available portals. So for example, if setting up a particular device, the location is important, what the technician can do is start the collection and then move a bit from the antenna and trying to find what, or rather where is the best location for that particular gateway. And here is just another example, which is more related to Wi-Fi, and it is gathering the information about the RSSI data of the network, the Wi-Fi interface. So here we have 4 devices connected. 2 of them you can see are stationary. Those were our laptops, while with 2 others we used our phones and tried to basically walk around and show the difference in the RSSI as we are collecting it. So one important note here is that the frequency of polling or getting this data or the data being pushed also relies on the manufacturers and how often do they change the data in the data model. But what we noticed recently is that a lot of manufacturers have taken note of this and have started really updating the data, which can then be used for monitoring or here for troubleshooting purposes. I am obliged to also tell you that this isn't a functionality which is only restricted to USP. This is also applicable for TR-69 sessions as well. We have an ability how to use the existing session and get the data as soon as possible. But the benefits of USP here are really in that because the messages are a lot smaller. In one pragmatic test, we noticed that the messages are even sometimes 4 times smaller. We can really push the devices to the limit in order to try to extract the meaningful data and to see what is actually happening on the device. So I call this a EKG of the device being used exactly at that moment when a customer calls that they have a problem or a technician needs help for setting up a particular router or a certain network element. Okay. And to be in time with what we said with the 45 minutes, I believe this is it. So thank you all for listening. Now we have some times for any questions you might have or any points you're interested in.
So Jure, so far, I do not see any questions in the questions box. I think you have done very well. It was quite interesting, and personally, me myself, quite impressed about the real-time streaming stuff on USP. If you do have questions, you can always ping Axiros and Yuri via our webpage. Clear. You can also book dedicated sessions with Yuri or with other solution engineers via our webpage to go deeper on this stuff. And of course, we are available at various shows throughout the year. Next week in Chitex in Morocco. In June, MIPRO in Opatija, Croatia, at the Angacom in Cologne, and last but not least, also in June at the TM Forum in Copenhagen. So you can also take chance to meet Yuri there and other people. Now I see some questions are coming in. Let me check, Yuri. There is one question from Skrapitz, Mr. Skrapitz. Hello and thanks for your explanation. Some of our customers use VLAN repeaters, extender nodes behind their CPE through port forwarding. Since we cannot communicate with those devices without the XMPP server on ACS, does that mean USP now allows the ACS to communicate with them without XMPP?
Correct. So in case those devices do support USP, you have then a dedicated port open for that particular device. No need for XMPP, no need for STAN or other ways in trying to mitigate these kinds of problems for devices which are behind either gateways or CGNAT.
Thanks, Yuri. Yeah, and having said this, wish you all a great Thursday and a good rest of this working week and some restful Easter vacations and good business in the future. So see you soon. Thank you, everyone. Bye-bye.
Bye-bye.